Alright, today we were focusing on the linear velocity lab. And the linear velocity lab is not too technical of a lab. What you're going to have doing is you have a car on the track running towards a motion sensor, something we already played around with during our exploration of Pasco. So you're going to have the motion sensor recording data. Also, you will have 3 hand timers spread throughout your track. I don't want to tell you exactly where to put them because depending on the 2 different sizes of track, you will have 2 different potential places to put your timers. Your 3 timers will all start the timers at the same time when the car is launched. As the car rolls down the track, each timer will in turn stop their timer when the back end of the car reaches their position. Back end of the car, back end of the car. Make sure that you are not having this 3rd timer be so close that they are hitting the motion sensor and trying to stop at the same time. Make sure there's a small gap there for that to happen. So you'll have data from the hand timers. You'll have a position and a time, a position and a time, a position and a time, and then you'll have the data from the motion sensor as well. These data, whatever, will be used together in your lab. As you gather this data, make sure that you're putting it into, maybe writing it on paper as you go or putting it into an Excel spreadsheet. You want to record it as you go. You don't want to take chances. Make a data table. When I run a data table, I like to have on my rows, I like to be each trial. On my columns, I like to be each piece of data from that trial. Position 1 time, position 2 time, position 3 time, and the slope of the line from the graph. This is the important data you will take from it. Okay? That is the physical things. Managing people is a big deal in this lab. You're going to want to have your person who is running the Data Studio program be the person who launches the car. It's much easier this way. They are hitting start on the computer. They are then launching the car. The car rolls along. The other people are timing. It is this computer person's job to be the coordinator of people. 3, 2, 1, go. And everyone starts at the same time. A bad run, the car goes off the track. A bad run, it launches, but somebody didn't time right. You don't record those runs. You just start over. Okay, moving over to the Data Studio part of it here. So you got your Data Studio graph of position. It's hard to see there, sorry, that's just where my screen capture is. Position versus the time. What I'm going to show you is I have a motion sensor sitting on my desk, and I'm going to move my hand towards it, just like your car will go towards the motion sensor. In your lab. So I'm going to hit start and do that here. Start, and then here's my hand over. See right there, it's recording my hand holding still. Now I'm going to move my hand towards the motion sensor in a relatively even fashion, and now I've hit the motion sensor. And that'll be good enough for us. Now it's recording the wall. Stop. So it's got like wall over by my phone, and then here's where my hand was in front of it, then my hand moved a little bit. Then we launched the car, so to speak. It went down with a relatively, yours will be very straight and clean right here, and then you'll hit the motion sensor, and then it might come back towards the other way. This part where you're going, you launched it, it's going towards the motion sensor, is the important part of your graph. You're going to want to highlight a portion, a good portion of that line. You want to have more than 2 data points in here. Highlight a good portion of it. Don't get the part where it's accelerating. Don't get the part where it's colliding. Just get the part where it's moving with a constant motion down the middle of the track. Then you want to go fit, linear fit. My linear fit says I have a negative 1.54 meters per second slope. Remember, rise over run, meters over seconds. I have a negative 0.154 meters per second slope, meaning I was going towards the motion sensor. The direction was towards the motion sensor. The positions were going from big number down towards 0. And I was moving my hand at roughly 15 centimeters per second. You'll see similar data with your cars, except for your numbers acceptable ranges of speeds. At 1 click, you're somewhere near 1 meter per second, perhaps a little slower. At 3 clicks, you might approach 3 meters per second. I wouldn't think too many of the cars would get over 3 meters per second. But those are numbers that you can expect. So you'll do this. I recommend that you delete your runs. Remove that. I hit experiment, delete the last run. Yes. I recommend that you delete each run as you go so as to clean it off once you get the data. Linear fit, I'm going to turn that off just because it's annoying me. You can actually leave it on if you're doing multiple runs though. That's what you're gathering with the physical data. Okay, Data Studio, here's my picture. That's the physical data. You're going to have hand timer data, and you're going to get velocity with your hand timers. You're going to get velocity from Data Studio, and you're going to make a comparison between the two to see how close you were at it. You'll do a % error between those, so you'll want to calculate that. I expect in 1 day of class, I expect you to gather all that data. If you get to the point where you can begin crunching the data, getting the velocities from your hand timers, then you're doing well. Alright, I'm trying to think if there's any other tips I can tell you on this. Other than safety, please be careful with the tracks. I don't want you hurting somebody. Alright, good luck. And I can't hit stop. Done.